Hi there, in this video we're going to start building up the RAM. Okay, so the last video we looked at, we had two 4x16 decoders. So if we were to take these decoders, then we could make a little matrix of all their outputs. And one would be a vertical one and one would be a horizontal one. So there's the two decoders, so these are 4x16, that's 4x16, which means it gets 4 inputs. And that one gets 4 inputs. This will have 16 outputs. Now if we make the 16 outputs vertical, so we just connect a wire to the outputs. So make that maybe wire 1, wire 2, and all the way along. Okay, and that would be wire 16. And then if we take the horizontal one and we take that and make that, say, wire 1, wire 2, all the way down to number 16, that's wire number 16. Then the way the decoder works is we get the 4 bits coming in here, and only one output will be alive depending on the value of the 4 bits. Okay, so we can make one vertical wire live and we can make one horizontal wire live from this one at any one point in time. So at any one point in time we have one particular horizontal and one particular vertical. Okay, so that means that at these crossover points we'll have 16 times 16, so we'll have 256 possible crossover points that will have gone live. Okay, one thing to note here is that these points here, they aren't actually touching one another. There's not a connection there. If you think it in 3 dimensions, they pass by each other but just close by each other, that's all. Now if we were to take a little memory cell or 1 byte memory cell and place it there, okay, and we could place another one there, and we place them next to these crossover points. Okay, so in effect they're just physically close to where these vertical and horizontal lines pass each other. Then what we could do is we could use this decoder to then choose which memory cell that we want to use, because we can take a connection from this memory cell, say here, and we can take a connection into the horizontal line, okay, sorry, the vertical line there, and we can take a connection into the horizontal line. Okay, so that means that when this vertical line goes live and this horizontal line goes live, both of these have gone high, and we can use both the fact that both of these have gone high inside this little memory cell in order to choose it. Okay, so that's a neat way of creating a little matrix for choosing all 256 memory cells. Now before I go into Logisim, just a little note here. Let's imagine that we had one memory cell. Now I'll break it into the 2 blocks. Okay, so one was the enable set section, the other one was the enable section. So that's one memory cell there. Okay, and again we've already built that up, so you've seen that, and there's one of them has got a set, one has got an enable, and this here is the set side, which is the little memory block. It reads in the data from the input and it stores it in the input whenever the set goes high and then low. Excuse me. Now this output here, this is the enable section, and what the enable does is when enable goes high, it allows the output here, it allows the output of the first section to pass on to the final output here. Okay, so the way we can think about it is the set goes high and we write to the memory cell. Remember, the whole thing there is just the memory cell. So set goes high and low, we write into the memory cell, we pass the data into the memory cell. Enable goes high, we pass that information to the output, so in effect we read from the memory cell. Okay, so set is to write and enable is to read. Now if we were to take, say, just 2 of these, well, we're actually going to have 256, but imagine we just had 2 of them. Okay, then we'd have our set and enable there for our other memory cell. And the thing to realise here is that all of the inputs are all tied together. So that input goes in there, okay, and all the outputs are all tied together. Right, and all the sets will be tied together, and all the enables will be tied together. Okay, when you go further up the hierarchy, these will all be tied together. So whenever the input comes in effect, the input comes into every single memory cell, and it just sits there, but nothing will happen to it until we actually choose which memory cell from this block here, we choose which memory cell will actually be reading or writing to. Okay, so let's go ahead and we'll show you in Logism how this little section's built up. So let's have a look here. There we go. So this is a little memory cell. Now if we drop down into it just as a reminder, so remember we built that up as a little memory block and then the enable block. So I'll just get in just so you can remember. So that's your 8 bits and that's a single bit of memory. Okay, so let's go back in here. Okay, so and in this side here was the enable section, which was all our ANDs passing that data through. Okay, so next byte. So now what we have here is our set and our enable. So our set will write to the memory cell, so it will pass this input, there's an I there, input into the memory cell, and it will store it in the memory cell. The enable will then allow that value to pass out to the output, so that will read from the memory cell out onto the bus. But the set and enable won't go high until, in this instance here, we've got 3 AND gates. It won't go high until both the inputs of the AND gates are high. Okay, so nothing will happen in the memory cell until this point here goes high, because it's tied in here and tied in here. So this memory cell will do nothing until this goes high. Okay, now that will only go high when both the inputs go high. And these inputs come from the little matrix of lines that we just seen a minute ago. So I put an H there, so the H is a horizontal, so that's a connection onto the horizontal, and that's a connection onto the vertical. Okay, so whenever the horizontal and the vertical connections go high, you can see it in this, so we've set both of them high, so that means that that little crossover section in the matrix is high. Then we know we're choosing this memory cell and we want to do something with this memory cell. Now at that point this is high and this is high, so then it says, well, what do you want to do with it? Now if we want to write into it, okay, then the set will go high, okay, and we'll write into it. If we're wanting to read from it, then the enable would go high and then we would be reading from it. Okay, so that's all that really does. Now I've added in an extra OR gate here. Now that's just so that I can reset all the values to 0. Okay, so when I toggle this up at the high level, then this reset is all connected together in every single one of these 256 bytes. So whenever it goes high, okay, it just reads in the input in here. Okay, so in effect it overrides this horizontal and vertical, and it just does it for every single one. So it allows me to reset every memory cell in a parallel fashion. Okay, so that's all it really is here. Now what we're going to do is, in the previous videos I've actually built up these little blocks. So remember we did mem1, mem8, enable and reg. Now I'm going to stop doing that now because I have already built the CPU and got it up and got it working, and it's going to take too long to go up and just sit and rebuild it, and I think it's much better if I actually from this point on I just look at the actual built one and explain how I've done it. Okay, so this was just as a lead in just to get started. So now the actual CPU design is in this folder here called CPU design. So you can see these are the first few here. that I built, and they're the same as the ones that I built up here. So the RAM is there, so it's 256 bytes. Now when I get in here, don't get phased by it, because all that's happened is we've taken this cell here, we've produced a hierarchy, we've taken 256 of them, we've connected all the inputs, all the outputs, all the resets, all the sets, and all the enables, all being connected together, and the decoders are there as well, and the little memory address register is there as well. So let's have a look. Okay, and there it is there. So I'll zoom out so you can see the whole thing. So there you go. Now it's quite small here, so I'll just quickly go through it on this page here. There's the vertical decoder there, and you can see all the vertical lines coming down. There's a horizontal decoder there, okay, and you can see all the horizontal lines coming across for that. There's a memory address register which just takes the input and breaks it into 4 bits, so there's 4 bits coming in here to control that decoder, and there's 4 bits coming down here to control that decoder, and there's an output and an input in the reset. So I'll zoom in so you can see these in a bit more detail. Okay, so there we go. So this here is just the block that we looked at in the last section. Okay, in fact I'll just kind of show you, and we can always come back in. So it's just that there. Okay, so let's go back to the 256. Now you can see the input coming in here, and all the inputs are all tied together. The outputs coming here, the outputs are all tied together as well. They're all in black. Okay, so the inputs there, outputs there, everything gets tied together. These actually go down to the bottom of the screen, and they're all tied together at the bottom of the screen. And you can see the decoder sections, all the wires, the horizontal and the vertical wires. Now that's the address there. So the address comes in here from somewhere in the CPU. So in the CPU we're going to request to read or write into a particular memory location. So we put the memory location in there. The memory location there at the moment is just all zeros, okay, and that is just a register, a temporary register, and it just passes all the data through whenever the set goes high. Okay, I'll just get in and show you that. So there's nothing fancy in there. It's just the same register as and it's the same setup as the little memory location. Okay, so whenever this is high, it passes in the address in here. The address gets split into 2, so 4 bits go to the vertical decoder and 4 bits go to the horizontal decoder. Now one other thing here that I added in, I've not actually mentioned, I'll get back in here just to show you, is this little output here. I actually added this in kind of retrospectively, because when I wanted to check and see, make sure the memory locations were working okay, so I took a copy of the memory and worked it up through the hierarchy so as I could see it at a top level here. Okay, so you can see that there. When I get in here, I've taken out this little connection here, it's just called output, and we get in there and we see where it is. It just sits there. Okay, so that's just the output of the memory location. So it's whenever we set the memory, that's what that memory location is set at, and I've just taken a copy of it and I'm just putting it out onto the hierarchy, a couple of hierarchies further up. Okay, that's all that's for. Now to see this working, we can pick a memory location. So as it stands right now, excuse me, the memory location is it's all zeros, so it actually goes all the way along and it's in the first row. Okay, so it's one of the first row, and then it's actually the very first column, so it's away at the far end. I don't think you can see it when we go along here because the way I've set up this drawn package. So I'll pick a different one. Let's see if we can pick something there. This one here. Find someone that's coming in here. 2. Okay, you can see the values here changing. So you can see that it's picked in this instance here. That's the first vertical line. Okay, so it's picked the first vertical line, and can I get this one there? Does it come down far enough? Okay, so there you go. So it's the first vertical line has gone live. Okay, and it's this particular horizontal line here that's gone live. Okay, so of all the 256 little memory cells here, this is the only one that has got both the vertical and the horizontal have gone high. You see, all of these other ones, the vertical's high, the horizontal's high there, but the vertical's not high because we're not choosing that line. So when we get inside here, you can see that we get inside, and we know that we're working on this memory cell, okay, because that's vertical and horizontal gone high. Now we have to decide on the set and the enable. Okay, now the set and enable, well, the set and enable, as I say, they all get joined together, and the set and enable all go back out of the RAM, and they'll go into the control section, and the control section will control whether we want to write to a memory location or read from it. Okay, so that's basically all there is here at the moment, and that's the entire block. Now I have to be careful because it can oscillate. So these little memory cells can oscillate. So I'm have to be careful in how I use this. But even if they do oscillate, I can always get in and just click the reset button and get everything back to the way it should be. Okay, so that's all there is for the RAM. So the next video we'll probably go in and we'll start looking at the ALU. Okay, thank you. Goodbye.